Awesome. So my name's Mugdha. I work on Chrome. I design web platform APIs and implement them for Chrome. And today, I'm going to give you a tour of some of the web APIs you can use to make your website offline enabled. But first, what do I mean by offline enabled websites? Now, if you launch a website today and you don't have network connectivity, chances are it's not going to load. It's going to take you to the generic browser page which says, sorry, no network connectivity. But if you launch a native app on your mobile, does it do that? No, it's likely going to still work reasonably well. So offline-enabled web apps are the apps, the websites, that continue to behave more like native apps in this regard. Even without network connectivity, they'll give you a reasonable experience. But why should we care? Everyone's on 4G these days. The world's moving on to 5G. So what is the need to support offline scenarios? Well, show of hands, who has been on an airplane recently? Yeah. And I'm from London. Part of my daily commute to work involves being underground for 40 minutes when we don't have network. Even overground, you can find yourselves on a train going through data-barren plains of the countryside. And also, you may choose to go offline, right? You may be outside your country, and your data provider's charging you an arm and a leg for roaming data. So you may choose to go offline. Now, here's a graph from a recent OpenSignal report that compares 4G speed to 4G availability. And you can see that with the exception of some Asia-Pacific countries, most of us are in this middle section here with not so great 4G availability and not so great speeds. And India is in this interesting position where availability is about 86%, but network speeds are abysmal. Now, this situation is made worse by the fact that video content is more popular in emerging markets. And that may be because that's an easier format to consume. The language barrier is low in that case. But what that ends up meaning for us, when combined with low network speeds, is that there will be long-running requests for large video files, which are going to time out. And that makes for a very frustrating experience for your next billion-user market. So hopefully I've convinced you that it's a good idea to make your website offline enabled. But another happy side effect of doing so is that it really turbocharges your page load times. Now, Harry touched on this earlier today, but when you increase your page load times, you have a huge positive impact on the revenues. So this is a study done by Walmart in 2012, which continues to be relevant today. And it shows that as the page load time increases from like less than 1 second to about 2 seconds, there's a sharp decline in conversion rates. And what do I mean by conversion rates? It's when a user is just casually browsing your website to when they actually become paying customers. If you really make your landing page fast, then you're going to increase sharply the number of people who actually turn into paying customers. OK, you're convinced. But you say that my browser caches pages. Why do I need to do anything? Well, what about pages that the user hasn't visited yet? Those aren't going to be cached. What if you want a finer-grained control over what parts of your page are cached? Let's say you don't change your images very often and only your text is changed. When the user visits one of these uncached resources, they'll be taken to the browser generic page. Now, for Chrome, that's this very interesting dino game, which I love, but it tends to get old after a while. And your users might not be using Chrome. You know, there are people in this room who will tell you that other browsers exist and are quite popular in some parts of the world. So somebody might remember App Cache. Has anyone heard of App Cache here? OK, one person. All right. Well, I should have built a grave for App Cache because it's full of gotchas. The spec for it is really hard to understand. But using it is like peeling the layers of an onion, and it's going to reduce you to tears by the time you're done with it. And even then, that's only the stuff you know about. There are all kinds of gotchas where it'll cache resources when you don't expect it to, and it won't cache them when you expect it to. So to deal with the flaws of app cache, service workers were designed. What is a service worker? Think of it as a proxy, which sits between your web app and the network. So it's going to intercept requests going to the network, coming from your web app, and it may choose to serve those resources through a cache. Because service workers are so powerful, and because they run after the user has navigated away from your page, we only allow websites rendered on HTTPS to use service workers. This is because no one wants to deal with nasty man-in-the-middle attacks, even after your users navigated away from the page. So let's quickly look at service worker lifecycle. You go from not having a service worker at all to having one that's being installed. And if that doesn't error out, then at some point your browser will activate the service worker. And once your service worker is activated, it's ready to use. If you don't use it, it'll go into idle state. And when needed, the browser will spin it up and use it to intercept requests to the network. How do you register it? So we're going to look at some JavaScript code, but pay attention to the highlighted bits. So in your web app, you can go navigator.serviceworker.register and provide the JavaScript file which contains your service worker code. The if conditional up top is just to check whether your browser supports service workers, but most browsers today do. So depending on what browsers you're targeting, you may skip that. Now, when does the browser install this? The service worker will only be installed if it's new. That browser has never seen this, or if it's an updated source code, so you've changed the code of it. When the browser installs your service worker, it's going to send you an install event. So in the service worker itself, you can add an event listener to the install event, and that's a great point to actually cache your static assets that you want to serve through this. Now, let's say you have pushed out a new version of your service worker. The browser won't load it until all the existing tabs that are using the older version are either closed or refreshed. Once that happens, the browser will send you an activate event, which you can listen to in your service worker. And that is a great point to delete old cached resources that won't be needed by this new version of the service worker. If you don't want to wait for the browser to, refresh the older tabs that were using the older version, you can use self.skip waiting, and that'll force activation of the new version. Right, now your service worker is ready, and it can start intercepting fetch requests. How do you do that? Well, surprise, you add another event listener. So you add an event listener for the fetch event, and then here you can see I'm responding with my fetch, which is a custom response that I can send to this fetch request. All right, this looks cool. You say, OK, I'm going to see if I'm online by using navigator.online and fetch as usual. Otherwise, I'm going to serve from my cache. Yeah. Navigator.online returns true a lot of times, a lot more often than it should. In fact, if you were to plug your Ethernet cable in a block of cheese, this would probably still return true. So you say, OK, I'm going to try doing a fetch instead of checking navigator.online. I'll just try doing a fetch, and if I miss that, I can return a match from my cache. That would work, except when you're in Li-Fi. What's Li-Fi? It's when your browser tells you that you're connected to the network, but you really aren't. Or that you're connected, but the connectivity is so slow that all your requests time out. So that's not a good strategy either. All right, we're going to switch strategies. How about I try to return a match from my cache first, and if that fails, I go to the network. Or even, you may say that you could go one step further and have a fail-safe static page that you can return even if the network request fails. That would work. But is it faster than not using the service worker at all? So let's look at this graph, which compares the time it takes in various scenarios. So the bottommost bar here is when you're not using a service worker at all, and that only involves network latency, right? All other bars are when you're using a service worker, and the topmost one is your best case scenario, where your service worker is active, you have a cache hit, you return a resource from the cache. You could have a cache miss and then have to go to the network. Or your cache is being really slow, and it tells you, sorry, don't have a resource, and then you have to go to the network. Or in the worst case, you have to spin up the service worker, your cache is being slow, it tells you it doesn't have the resource, and then you have to go to the service worker, through the network. So actually, you can see that in a majority of the cases, we are worse off when we're using the service worker. So what am I talking about here? Well, do we have to do the two requests one after another? No, right? We can make them race. We can try to get the resource from the cache and simultaneously also try to fetch it from the network. And whichever one succeeds first, we present that to the user. And if the network request comes through later, we can present the updated content to the user. And that is indeed the right way to use service workers. But can we make the case where we don't have the resource cached and we also don't have network connectivity better? So if you recall, we were showing a static failsafe page. Can we make that better? That's where background sync comes in. Now, background sync is an API through which you can tell your browser that, hey, when I have network connectivity next, do something. That do something can be loading an article, or it can be sending a post message to a server, right? With background sync, if the user clicks on an article, for example, that you don't have in the cache and you don't have network connectivity, you can show something like this. Uh-oh, you've come across a slow-loading article. Why don't you let us load it in the background, and we'll let you know when it's ready? And that's a much better experience for the user, right? How might I do this? So you'll see this pattern a lot in this talk. In your web app, you get your service worker registration, access the sync object, and call register on it. And then you provide a tag. This is for you to work with later. In your service worker, you add an event listener for the sync event. The sync event will be sent when the browser realizes that you have network connectivity. And in the sync event, you can check for the tag. Here, I'm trying to get the latest articles on Brexit. And you can basically, when you have network connectivity, get them and update. And either notify the user or just update content on the page. Now, this is also really great for web apps that let you do something. For example, you have a messaging website, and the user's typing a message, and you lose network connectivity. What you can do is package everything you'll need to send that message and register a background sync event, so that when you have network connectivity, that message can be sent, and the user won't even know that you lost connectivity in between. So that's great for short tasks, but what about videos? Because the thing is, service workers are so powerful that we restrict the amount of time they're allowed to run for. It's in the order of minutes. Now, if you remember India, where network speeds are low, if you try to download a video on the service worker, it's still gonna time out. It's not gonna finish within order of minutes, right? And so we're no better off. That's where background fetch comes in. Now, this is a new API, and this lets you offload the download or upload to the OS itself. So your download is going to persist across losses in network connectivity. It's going to even persist across browser restarts, because you've handed it off to the OS. And what we require is that the browser shows some kind of UI throughout the duration of the download, so the user is aware that their data is being used. They can pause the download if they want to, they can cancel it if they want to, and they can interact with the finished download. So let's quickly look at how we might do this. So in our web app, again, we would get the service worker registration and access the background fetch object on it and call fetch. In Fetch, we can specify an identifier, which is for us to uniquely identify this fetch, and an array of resources that we want to download. For example, here I'm downloading episode 5 of a podcast, and I'm also downloading the associated artwork that'll go with it. These are things that'll go in the UI. So, for example, Chrome shows a notification, and this is the title of the notification. So you can tell the user that you're downloading episode 5 of the podcast, and any icons that'll go with it. Download total is a hint to the browser that this is the size of data that I'm trying to download. And the browser will do a check against your quota to make sure that you're not going to exceed it before it actually uses up the user's data plan. In the service worker, you can listen to the background fetch success event, which will be sent once the download completes. And in here, you can use the match all method to get all the request response pairs and get all the responses of all the requests you had requested. And then you can put them all in a cache and serve them from the cache to the user next time they're needed. This also lets you update the UI to say that, hey, episode 5 is now ready to listen, inviting the user back to your website to either take them to the relevant web page or just start playing the podcast at that point. But can we be more proactive? So far, we've looked at background sync and background fetch, both of which require the user to go and click on a resource, and then we start downloading. But the website knows when they have updated content, right? So they can be a bit more proactive. This is where web push comes in. This requires us to write a server that speaks the web push protocol, but once that's in place, the server can send a push message to the client whenever it has updated content. And the client can listen to the push event in the service worker, and once that happens, it can either start downloading the updated content or simply show a notification to the user saying, hey, you have updated content. For example, new podcasts are available. That'll invite the user to click the notification and come back to your website, rather than waiting for the user to come to your website and then clicking on a link to download that resource. Now, you may have noticed that I sneakily avoided explaining how to set up the server in the previous slide, and that's because I don't think you need to. Can we make do without a server? Now, this is very exciting to me because I'm currently implementing this for Chrome. It's periodic background sync. This is an extension for the background sync API that we talked about previously. And with background sync, you can tell the browser to do something on network connectivity. With this, you can tell the browser to do something periodically whenever we have network connectivity. So for example, you can tell the browser that every 24 hours, update my website, update the cached resources for this website. And the browser can actually be smart about it. The browser can say that, hey, this user visits this website at 8 a.m. every day, so at 7:45, I'm going to update it. Or the browser can say that this user hasn't actually been on this website for the past 20 days, so I'm going to stop running the periodic task that this website has requested. Or for example, this website is visited much more often than this one, so I'm going to let this task run more frequently. How do I do this? In my web app, I access the service worker registration, the periodic sync object on it, and call register. Now this looks very similar to background sync so far. The exception, or the extra bit, is that we specify a min interval, and this is the minimum interval at which you want your periodic task to run. In your service worker, you listen for the periodic sync event, and when you get that, let's say you're trying to fetch and cache the latest news because your user visits your site every morning, you can do that periodically. So all of these APIs are really great and powerful. But like another speaker said earlier today, with great power comes great responsibility. So it's important for us to respect user resources. And this builds goodwill with the user. This actually ensures that the user will keep coming back to your website over and over again, and it will actually end up being better for both of you in the long run. So what are some of the ways in which we can do this? First up, it's good to be mindful of what situations your website will be used in. A lot of websites are used globally now, and we remember emerging markets, they have very slow network speeds. So Chrome Developer Tools gives you an ability. So if you go in the Network tab, it'll let you simulate slow 3G, fast 3G, offline. So it'll let you throttle the network. And this is really good to test your website before launching it in these markets. Another thing we can do is look at Navigator connection effective type. Now, this lets you deduce what kind of network your user's on. And if they're on slow 2G, 2G, slow 3G, we can choose not to cache aggressively. We can choose to only pre-cache critical resources. And vice versa, if the user is on Wi-Fi, that's a time to actively prefetch all the resources we may need in the future. A third way is that a lot of browsers will set this field in the HTTP request header, save data, if the user has turned on the data saver mode in their browser. So it's good to, Harry talked about resource hints earlier today. This is kind of the flip side, when the browser is telling the website that, hey, the user has chosen that right now is not a good time to use their data. So it's good for us to be respectful of that user choice and do something similar and pre-cache very few resources if we're in the data saver mode. Lastly, you'll remember background fetch. Those are long-running downloads, long-running uploads. They eat up a lot of data. So it's actually good to give that control to the user. Let them decide which resources they want to be downloaded for later use. This can be done by having UI controls like a button that says save for later. So for example, if you have a podcast app, let them choose which podcast they would actually want to save for next time. And I would like to touch on some debugging testing tools. Chrome Serviceworker internals is a great page to actually, later today when you have some time, go and look at what service workers are running in your browser right now, because you might be using a lot of them without knowing that you are. It tells you the state of each of them. It lets you unregister them, upload them, play around with them. But even better is the Chrome DevTools UI. So under the Application tab, there is a Service Workers panel. And this lets you simulate offline conditions. You can click Update on Load, and that'll do the self.skip waiting thing I talked about earlier, where you don't have to wait for previous versions to be unloaded. You can immediately load the newer version of your service worker, and that's quite useful when debugging. You can basically look at the status of each service worker and send push events and sync events from it to test how your app behaves under those. But also, service worker is just a JavaScript. It's a piece of JavaScript, so you can add a debugger, line debugger anywhere, and it'll break into the debugger, and from there you can step through. And it's really useful that way. If you use Visual Studio Code as your IDE, I recommend Live Server extension. This really helps just hosting a site right away and testing what it would look like. There's a similar Chrome extension called Web Server for Chrome, but my favorite is Github Pages. Github Pages lets you host dynamic websites, and that is what I personally use to test some of the powerful APIs that I talked about. And that's it. I have some references linked from here, so reach out to me later to get these slides. And yeah, that's good to read. If you have any feedback about periodic background sync or any of the APIs I talked about today, please reach out to me. My email is nader@chromium.org. Thank you.